Alright, today's activity is going to focus on the concept of dry matter and as fed. These are the reading notes that we'll be kind of working through and discussing a little bit, plus some of the calculations and formulas are in this handout. So I'm going to recommend that you have a hard copy of this handout available to you as we are moving through it. This is actually week 3, so just ignore the fact that it says activity 2. It's still the same content. So the primary concept that we're going to be working with today is the fact that we want to understand kind of what's in a feed. So if I have a bag of feed, and in that feed we have all of our nutrients that we've been discussing. For example, one of the major nutrients is water. That feed is going to have some amount of water in it. We're going to have some fats or lipids or something like that that can supply energy. We're going to have carbohydrates in there. And those carbs can be either in the form of fiber or sugars, one or the other. And then we're also going to have things like proteins, vitamins and minerals, and those types of things in our feed. That's the purpose of feeding livestock, is that we're going to balance what's in that feed with what the animal needs. And we may need to blend feeds periodically to be able to make sure we're getting the right nutrients to our animal. So when we take a look at this, this is what we call as fed, as it's presented to the animal. And sometimes when we balance diets, especially on the herbivore diets or animals that are on high forage, we like to consider what we call the dry basis or dry matter. And that's where we remove the water. And when we do this, we still have a level of fats. We still have the level of carbohydrates. And we still have the proteins and minerals and all of that stuff that's also in there. And vitamins and minerals. So we still have all of our nutrients other than water in a highly concentrated package. So when we're talking about converting between the two, because a lot of times we have to be able to work between these two bases for representing feeds. And so we need to be comfortable going back and forth. So when we think about, there's two ways we can express nutrient needs. The first is a weight basis. And that is simply pounds or grams or kilograms or any unit of weight. And when we look at these two, which one is heavier? It's probably going to be the one that has the water in it. So as fed is always heavier weight, and dry matter will be lighter. Because we've pulled the water out, so we've pulled out some weight. We also deal with a concentration basis, like percentages, or calories per pound, or parts per million. And so when we take a look at a concentrated nutrient, like percent protein or percent fat, we are actually going to have higher concentrations when water's removed, and we're going to have lower concentrations when the water is present, because water can act as a diluent. It actually dilutes the concentration of nutrients. So if we're looking at concentration basis, dry matter is going to be the higher value. When we look at weight, as fed is heavier. So when we're going through this process, we're going to be multiplying, we're going to be taking a value, and we're going to be using the dry matter percentage from each feed. And we are either going to multiply it or divide it, depending on which direction we're going. If we take an amount and we multiply it by something, we are going to get a smaller number. If we divide, we're going to get a bigger number. So for example, if we're working on weight and we're given an as-fed weight, we know we're going to multiply to get the smaller number. If we're given an as-fed concentration, we're going to divide because we need to get to a higher number. And so that's the concept that we're going to be working with on our problem sets. Alright, our first example is going to be problem number 1 from the problem set. This is the activity that you have available to you on Blackboard. And so we're going to do a couple of the problems as examples to explain the concepts. The first one we're going to do is the problem involving Thomasina, an Angus cow, who was my actual cow back when I was a kid. And she's averaging 1,000 pounds and is eating 3% of her body weight in dry matter each day from perennial ryegrass pasture. And so one of the questions is asking how many pounds per day of dry matter is she eating. The second question is how many pounds of pasture as fed is she eating. And then we want to know how many mcals of net energy for maintenance is she eating per day. So we need to know pounds of dry matter as fed and the calories she's getting each day. So the first thing we need to do is determine how many pounds of dry matter is she eating per day. So I'm going to just scoot the problem up a little bit. So for problem 1, she is 1,000 pounds. And just a note, hashtag in my language means pounds, because otherwise if I write LB it's sometimes hard to distinguish from a 1. So hashtag means pounds. Make a note of that. And she's eating 3% of her body weight. So we need to find 3% of 1,000. And so when we have a percentage, we are going to divide it by 100 to get the decimal form. So to figure out 3% of 1,000, it's going to be 1,000 times 0.03, which if we want to pull it up on the calculator just for illustration purposes, should be 30 pounds. So she is eating 30 pounds of dry matter per day. And I'm a big fan of always labeling everything you do, just so that you can keep things clear and organized as you're working on them. So that is problem A. How many pounds of dry matter is she eating per day? Now the next step, which if I was a little bit better prepared I would have had ready to go, is to find out perennial ryegrass pasture, because according to the problem she's eating perennial ryegrass pasture, feed group 2, IFN number 2-04086. So that's going to kind of help make sure we get the right one. And what I'm going to do is kind of flip the page until we get to ryegrass. Rye fresh, nope, I want ryegrass. Alright, 20486. So from the perennial ryegrass, what the information we're going to need is we need to know the percent dry matter, which in this case is 27%, and we also need the net energy for maintenance, which is 1.57. Now it's important to note that in this textbook it is represented in megacalories per kilogram. So we're going to have to do a little bit of manipulation, and we'll walk through that process. So, before I forget, we have 27% dry matter and 1.57. But let me double check it. Yep. 1.57 megacalories of net energy for maintenance per kilogram. Okay? So the second step, problem B, is we want to know how many pounds of pasture as fed. So we know she's getting 30 pounds of dry matter. Now we ask that question, do we need a bigger or smaller number? And we should realize that if we're adding water back into it, we need a bigger number. And so to get a bigger number, we're going to divide by the percentage dry matter on a decimal form. And so what we find out is if we take that 30 pounds divided by 0.27, that she needs 111.11 pounds as fed daily to get that percentage dry matter. And when we have high moisture forages, it can triple what they need to consume per day to be able to get that dry matter value. So that's how we solve problem B. How many pounds of pasture as fed is she eating daily? The third question is, okay, we know that she is eating 30 pounds of dry matter, and we know that dry matter is 1.57 megacalories per kilogram of dry matter for net energy for maintenance. So we need to convert this, either the pounds to kilograms or the concentration to pounds. So what I typically do, and this is where you need appendix table, I believe it's 6 or 7, or 77, sorry, it's way in the back of the book. But this is going to give you all your weight conversions. And so 1 kilogram is 2.205 pounds. So we've got to be able to convert that. And so what we know is that this is the same as saying 1.57 in 2.205 pounds. Okay? If that's over 1 kilogram, these two values are the same. So if we reduce that and take the 1.57 divided by 2.205, then we have 0.71 megacalories of net energy per pound of dry matter. Sorry, I run out of space on the side. So now we know that in 30 pounds of dry matter, if each pound contains 0.71 megacalories, we simply multiply times that density, and that will tell us that Thomasina is eating 21.30 megacalories of net energy for maintenance per day. That's the answer to C. Okay, so I want you guys to take a second and work through problems 2 regarding Wanda the quarter horse, which also was my horse growing up, and the cats on problem 3. And this one you will need to Google the pet food and find the nutrient profile chart to be able to answer those questions. So go ahead and take a minute and do these 2 problems, and then come back and we'll work on the next section of material. Alright, the second type of problem we're going to do is going to be converting nutrient concentrations between dry matter and as fed. The previous example we were converting weights back and forth. Now we're going to be converting concentrations. So we need to we're going to work on problem 4 and problem 7 as examples. So problem 4 is dealing with, let's set up a little bit better so that you guys can kind of keep up, alfalfa silage. And so right now we are told that it contains 6.25% crude protein as fed. So what we want to know is the percentage of crude protein on a dry matter basis. And to do these problems, it's really handy to set up a little cross multiplication factor. So we know that on the dry matter basis, it's going to be out of 100% dry matter. What we need to know is what the as-fed basis is out of. So if we go to our handy textbook, as promised, you will use this heavily, we are going to look up alfalfa silage. And alfalfa silage, the correct one, checking our IFN number, is 300217 is 38% dry matter. So we're going to set that up over right here. So on a 100% as-fed basis, what we're saying on 100% as-fed, 38% is dry matter. And in that, 6.25% is crude protein. What we want to know is just strictly on the dry basis, 100% dry matter, what is that new concentration of protein. So to solve for this, we simply cross multiply. So 6.25 times 100 is 625. It's going to equal 38x. Divide both sides by 38. X is going to give us 16.45% crude protein on a dry matter basis. So does it make sense that we went from 6.25 to 16.45? We got a larger number because we removed the water, removing the dilution, and increased the concentration of crude protein in that feed. So that's an example of how we go from, in this case, we are going from an as-fed percent to a dry matter percent. Okay? Take a second and go ahead and do the next couple of problems and get comfortable with moving that direction. Okay? The other two are set up very similar to this. Okay, so just to review that concept on converting concentrations from dry matter to as-fed, I want to clarify that little formula we used last time. If we have the concentration on an as-fed basis and that the percent dry matter, which is also technically as-fed, that's going to be the same as the concentration of dry matter out of 100% dry matter. And so that's how we can put, depending on which concentration we're given, we can set that up for any problem. So for example, problem 7 is corn silage, and it contains 44% NDF on a dry matter basis. So we're going to be setting that up on this side of the equation. What we want to know is the percentage of NDF on an as-fed basis. So we still need to look up the dry matter concentration of corn silage. So if we come into our book and scroll down to find corn silage, and we always verify our IFN numbers. 250 is the last one. This is it. The dry matter concentration is 33%. So that's going to be x over 33. So now what we do know is we're going to have 100x equals 44 times 33, which gives us 1452. We're going to divide both sides by 100 to isolate x, and that's going to be 14.52% NDF as fed. So think about it. We were given the NDF concentration on a dry basis, so we're adding the water back in. We're going to dilute it, so we should have a smaller value. And that is how you convert between concentrations, dry matter and as fed. So take a moment and finish up 8 and 9, and then I'll walk you through an example of estimating a nutrient content of a total feed mix. The last type of problem that we're going to be working on this homework is estimating, get all of that, the nutrient content of feed mixes. And so we're going to actually do example or problem number 12 as an example. And to save time in the video, I've already looked up the data that we're going to need. The problem gives us the amount of each feed in the mix. Okay, so this is actually like a what you sometimes hear called a cob mix, corn, oats, and barley with a little bit of molasses. I've looked up the percent dry matter, and I've looked up the megacalories of net energy for maintenance per kilogram. So the first thing we need to do is convert to megacalories per pound. And to do that, we simply divide by 2.205, like we did in a previous problem. So I'm just going to run down the list and divide each of these values by 2.205 and round to 2 decimals, and that's going to give us the mcals per pound of dry matter. Okay, so now we have all the information we need to complete the problem. Okay, the first thing that the problem asks for is part A is the percentage dry matter of the mix. So what we need to do first is determine how many pounds of dry matter we have coming from each nutrient, because that's what's going to dictate our total percentage of dry matter. So I build tables. So if we know that we have so many pounds as fed, 1,000 pounds of corn, 300 pounds of oats, 670 pounds of barley, and 30 pounds of molasses. This was given to us in the problem. We know that the total is 2,000 total pounds. Okay, so to figure out how many pounds of dry matter we have in each ingredient, we know we're going from pounds of as fed to pounds of dry matter, so we need a smaller number because we're removing water and it should be lighter. So we are going to multiply by the dry matter percentage. Okay, again, these are these values right here that I've already looked up. And so we're going to take 1,000 times 0.86, which should be 860. 300 times 0.91, which is 273. 670 times 0.88, which is 589.60, and 30 times 0.78, which is 23.40. So now we know how many pounds of dry matter is coming from each ingredient. We simply need to total it up. So I'm adding all these values together, and I get 1,746 pounds of dry matter. Now, if we know a percentage is simply the same thing as a part over a whole times 100. Okay? So if I am asking for the percentage dry matter, then we're going to take the part, which in this case is the 1,746 pounds of dry matter, okay, over our whole, which is going to be the 2,000. And we multiply that times 100 to get our percent dry matter. Which is 87.30% dry matter. And if we take a look at just our visual dry matter numbers here, it makes sense that 87 is kind of in the middle of where these values are at. So that is a reasonable answer. So that's the answer to part A, is simply taking the amount times the dry matter percentage to get pounds of dry matter. Okay, the second part of this is asking about what is the concentration of net energy in this mix in megacalories per pound of dry matter. So we know that we have 860 pounds of dry matter from corn. Okay, that's these values here. 273 from oats, 589.6 from barley, and 23.4 from molasses. We also know that our total pounds of dry matter is 1,746 pounds of dry matter. So what we need to determine is how many megacalories is in each ingredient. So we've already converted our megacalories up here to megacalories per pound of dry matter. So now it's a simple multiplication. If we multiply times the megacalories in each pound times the poundage, we're going to get total mcals. Okay, so if we run these through the calculator real quick, 860 pounds times 1.08 megacalorie of net energy for every one of those pounds, we get 928.8 megacalories. We take the 273 times 0.85, 232.05, 589.6 times 0.93 equals 548.33. In this case, we want to make sure we're rounding to 2 decimals. 23.4 times 0.87. And now we just sum up our answers. So we know that we have 1,729.99 mcals in this many pounds of dry matter. And so we can have more than 1 megacalorie per pound of dry matter. And so the question, part B, is asking us for megacalories per 1 pound of dry matter. So we're going to take our megacalories, right here, and divide it by the pounds of dry matter. So what we come up with is 0.99 megacalories per pound of dry matter for this mix that contains corn, oats, barley, and molasses. And so it is a little bit tedious, but it is a very straightforward process in which we're going to be figuring out nutrients. Now, when we're working with calories, we keep these numbers on a per pound basis, but if we were dealing with a percentage, you would want to move the decimal 2 places to the right or to the left. It's the same as dividing that percentage by 100 to put it on a decimal form. So there's 2 other nutrient contents to estimate. So I'm going to go ahead and let you guys figure out those 2 problems, number 10 and 11.